Good evening, students. Today we are going to start today's class. First sum is determinant given that a plus b plus c equals 0. Then we have to find the value of one determinant, and the determinant is determinant 1 cos c cos b. This is cos c 1 cos a, then cos b cos a 1. Now we have to expand this determinant and we have to get the value of it given that a plus b plus c equals 0. So expanding, we have 1 into 1 minus cos square a, then plus cos c, we have cos a cos b minus cos c, then plus cos b, we have cos a cos c minus cos b. Clear? Now this is equal sin square a, and from this we have minus cos square b. So sin square a minus cos square b taken together. Now cos a cos b cos c plus cos a cos b cos c. So we have twice cos a cos b cos c. And then we have here minus cos square c. Now this is equals sin square a minus cos square b. This is equals minus cos of a minus b into cos of, this is equals minus cos b minus a, or we can add a minus b also because cos of minus theta is cos theta. So cos of b minus a into cos of b plus a. Now this is plus cos c. Then we have 2 cos a cos b. 2 cos a cos b formula is cos a plus b plus cos a minus b. Then we have minus cos square c. Now this is equals minus cos b minus a. Now cos b plus a, since a plus b plus c equals 0, so from this we have b plus a equals to minus c. So here we get cos of minus c. Now cos of minus c is cos c. So cos b plus a becomes cos c, as a plus b plus c equals 0. So this into cos c plus cos c into, this is cos a plus b, so again it becomes cos c. So cos c, because a plus b plus c is 0, so a plus b equals minus c, and cos of minus c is cos c, plus cos a minus b, then minus cos square c. So next step we have, this is equals minus cos c cos a minus b. We can add a minus b or b minus a because cos of minus theta is cos theta. Now plus cos square c minus cos square c gets cancelled out. So we have plus cos c cos a minus b, and these two terms gets cancelled out, so we get the value of the determinant equals 0. So the value of the determinant is 0. Let's proceed to the next sum. Next sum is find the value of theta such that determinant 1 sin 3 theta, then we have minus 4 3 cos 2 theta minus 7 plus 7 minus 7 minus 2. This is equal to 0. This is given to us and we have to find the value of theta. So let's expand the determinant. So expanding, we have 1 into, this is minus 6 plus 7 cos 2 theta. Again plus 1 into, this is 7 cos 2 theta minus 8. Then plus sin 3 theta into, we have 28 minus 21, and this is equal to 0. Now this gives 7 cos 2 theta, and again here 7 cos 2 theta. So we have 14 cos 2 theta. Then we have minus 6 minus 8 minus 14, and this is 7. So plus 7 sin 3 theta equals 0. So this implies sin 3 theta plus 2 cos 2 theta minus 2 equals 0. Now we know that in trigonometry in class 11 we have the formula for multiple angles sin 3 theta. The formula for sin 3 theta is 3 sin theta minus 4 sin cube theta, and formula for cos 2 theta in terms of sin theta is 1 minus 2 sin square theta. So let us express this expression in terms of sine theta. So this is implies 3 sine theta minus 4 sine cube theta plus 2 into 1 minus 2 sine square theta minus 2 equals 0. Now let us rearrange in descending order of degree of sine theta. That is, first we will choose sine cube theta. So 4 minus 4 sine cube theta, so it will become plus 4 sine cube theta, as we are multiplying the equation by minus 1 and rearranging. Now we have minus 4 sine square theta here, so it will become plus 4 sine square theta. Then we have plus 3 sine theta, it will become minus 3 sine theta. And this minus 4, and we have here minus 4. Plus 2 minus 2 gets cancelled out. This is not minus 4, this is 2 into 1, 2, and this 2 and plus 2 minus 2 gets cancelled out. Now from this we have sine theta common. So taking sine theta common, we have 4 sine square theta plus 4 sine theta minus 3 equals 0. Now this is equal to sine theta into 4 sine square theta, middle term factorization. So factorizing this by middle term factorization, we have 4 sine square theta plus 6 sine theta minus 2 sine theta minus 3 equals 0. Now let us solve the upper portion. As this type of sums are very lengthy, so we need a larger board, but due to space problem I can't use a larger board here. So that's why sometimes having problem solving lengthy sums. So we have to rub more space is required. So this is equal to sine theta into curly bracket. We have 2 sine theta common, so we have 2 sine theta plus 3, and from this minus 1 common, 2 sine theta plus 3 equals 0. So now we are factorizing, we have sine theta into 2 sine theta minus 1 into 2 sine theta plus 3 equals 0. So this implies, now this is the product of 3 terms. Product of 3 terms is 0, so one of them must be 0. So this implies sine theta equals 0, or we have sine theta equals to half by equating this equals to 0, or we have sine theta equals to minus 3 by 2. Now this value is not possible, as sine theta belongs to closed interval minus 1 comma 1. So the value of sine theta can never be less than minus 1. So we neglect this value. Now from this we have sine theta equals, theta equals to n pi. Now theta equals to n pi, and from this we have sine theta equals to n pi plus minus 1 whole to the power n pi by 6. So the values of theta are n pi comma n pi plus minus 1 whole to the power n pi by 6, n belonging capital I. Next we have next sum. Now next sum is, if determinant 4 minus x, 4 minus x, 4 minus x, all diagonal elements are 4 minus x, and non-diagonal elements are all 4 plus x. If this determinant equals to 0, then find the value of x. Or sometimes the question is given in board exam as solve this determinant. So let's operate R1 operating R1 plus R2 plus R3. So operating we have determinant. Now if we add these rows, the R1, R2 and R3 together, plus x minus x gets cancelled out. 4, 4, 8, 8 plus 4, 12. So we have 12 plus x. Here also 12 plus x, here also 12 plus x. And other rows will be no change because we have operated only on R1. So R1 will be changed. Now, others are 4 plus x, 4 minus x, 4 plus x, 4 minus x. This is 4 plus x and this is 4 plus x. This is equal to 0. So we have 12 plus x out of the determinant. It's common from first row. So we have determinant 1, 1, 1. Then we have 4 plus x, 4 minus x, 4 plus x. Then we have 4 plus x, 4 plus x, 4 minus x. This is equal to 0. So we have either, if we take this value as 0 or this determinant as 0. If we take this value as 0, then the value of x is minus 12. So either x equals to minus 12 or determinant 1, 1, 1, 4 plus x, 4 minus x, 4 plus x, 4 plus x, 4 minus 4 plus x, 4 minus x. This determinant equal to 0. Now we have to see what value is coming from this determinant. Now if we take determinant 1, 1, 1, then 4 plus x, 4 minus x, 4 plus x, 4 plus x, 4 plus x, 4 minus x. The determinant equal to 0. So we have to make it this 1 equal to 0 so that we get the structure of 1, 0, 0 and we can delete the first row and first column. So we operate C2 operating C2 minus C1 and C3 operating C3 minus C1, or we can use C3 minus C2 also, no problem. So we have this implies determinant 1, 4 plus x, 4 plus x. Now this 1 minus 1, 0, 4 minus x minus 4 plus x is minus 2x, and this to become 0. This minus this 0, this minus this 0, and this minus this is minus 2x. This is equal to 0. Now we can see that minus 2x can be taken common from column 2 and from column 3 also. So in outside we have minus 2x whole square. Then we get 1, 4 plus x, 4 plus x, 0, 1, 0, 0, 0, 1. So in the third column we see the structure of 0, 0, 1 has come. So we can delete this determinant. So by deleting this determinant we have 4x square. Then expanding we have determinant 1, 0, 4 plus x, 1. This is equal to 0. So expanding we have 4x square into 1 minus 0 equals 0. Imply x equals 0, 0. So we can conclude that the values of x are, one was minus 12 and another is 0, or we can say minus 12, 0, 0, because both the values are same. Okay, so up to this we have next sum is based on. So this is our next sum. Given that a1, a2 dot ar are in GP, then we have to find the value of ar plus 1, ar plus 5, ar plus 9, ar plus 7, 11, ar plus 15, ar plus 11, ar plus 17, ar plus 21. Now we know that if we take that let capital A be the first term and capital R be the common ratio, then we have AR plus 1. AR plus 1 is like TR plus 1. So what is the formula? Is AR to the power n minus 1. That is capital A R to the power R. Because in our problem, small a, that is the first term of the GP, is capital A, and the common ratio is small r in book. So but here small r is the term number. So we have used capital R as the common ratio. So it becomes capital A R to the power R. Similarly, AR plus 5, this becomes capital A R to the power R plus 4. So in this way we can find the values of each and every element of this determinant. So let us put the values in this determinant. So first we have the first value, capital A R to the power R. This is capital A R to the power R plus 4 capital A r to the power r plus 8. Now we have this one, capital A r to the power r plus 6, capital A r to the power r plus 10, capital A r to the power r plus 14. This is capital A r to the power r plus 10. This is capital A r to the power r plus 16, capital A r to the power r plus 20. Now we can see that minimum value in the first row is capital A r to the power r. Second row, capital A r to the power r plus 6. Third row, capital A r to the power r plus 10. So we take common capital A r to the power r from first row. From second row, we take capital A r to the power r plus 6. And from third row, we take capital A r to the power r plus 10. After taking common, we have determinant. First row becomes 1, r to the power 4, r to the power 8. Second row becomes 1 as we have taken a r to the power r plus 6 common. Second element becomes r to the power 4 and this becomes r to the power 8. Now third row, this becomes, we have taken capital A r to the power plus 10, so it becomes 1. This becomes capital A r to the power 6 and this becomes capital A r to the power 10. Now we can see the first row and second row becomes identical, so the value of this determinant becomes 0, because in determinant if any two rows or columns are identical, the value of determinant becomes 0, so the value of this determinant becomes 0. We can write since r1 identical r2, that we can write. So 0 into this equals 0. Next we have show that if determinant, it is given that 1 plus cos A. This is very important determinant for board exam and school exams. This is very important determinant for school exams and for board exams. So please practice this determinant very carefully. This determinant, I think it is given in NCERT. Even you can check it, and it is given in Anas Agarwal also. So this is a very important determinant. 1 plus cos B. This is 1 plus cos C. This is cos square A plus cos A. This is cos square B plus cos B, and this is cos square C plus cos C. This determinant equals to 0. This is given. So if question is that if this determinant is 0, then we have to prove that triangle ABC is isosceles. Clear? Triangle ABC is isosceles, where capital A, capital B, capital C are the angles created at the vertices of the triangle ABC. So we can see in this determinant that the first row is 1 1 1, so we have to make it 1 0 0, so that we get the pattern of 1 0 0, and we can delete the first row and first column to get a 2 by 2 determinant from this 3 by 3 determinant. So what we do that C2 operating C2 minus C1 and C3 operating C3 minus C1 or C2. So let us choose C2 operating C2 minus C1 and C3 operating C3 minus C2, or we can choose C1 also. So choosing, we have first column will become no change because there is no operation on C1. So we have 1 plus cos A, cos square A plus cos A. Next we have, this is 0. Now 1 plus cos B minus 1 plus cos A. So this is cos B minus cos A. Now this one, cos square B plus cos B minus cos square A plus cos A. So we have cos square B minus cos square A plus cos B minus cos A. Clear? And this determinant becomes 0. This is cos C minus cos B, as we have chosen C3 minus C2. Then we have, this is cos square C minus cos square B plus cos C minus cos B. This determinant equals 0. It is given. So now we have get the pattern of 1 0 0. So we delete this determinant. After deleting, we can see that we get this 2/2 determinant in which we have cos square b minus cos square a, whose formula is cos b plus cos a into cos b minus cos a, like a square minus b square equals a plus b into a minus b, similar. And we have cos b minus cos a here also, and here also cos b minus cos a. So we can take cos b minus cos a common from this second column. From third column, similarly, we can see cos c minus cos b can be taken common. Now, if we take cos c minus cos b common from third column, then we have there 1, here 1 plus cos c minus cos b. So we take common of cos b minus cos a, this from second column, and cos c minus cos b from third column into cos c minus cos b. So after taking common, we have here 1, here also 1, and here we get 1 plus cos b plus cos a, and here 1 plus cos c minus cos b, cos c plus cos b. So we get this determinant, and this is equal to 0 given. So we have cos b minus cos a into cos c minus cos b. Now expanding the determinant, we have here 1 1, we have 1 1, and this is 1 plus cos a plus cos b, and this is 1 plus cos b plus cos c. So expanding this one, we have 1 plus cos c plus cos b minus 1 minus cos b minus cos a equals 0. So we have cos b minus cos c into cos c into cos c minus, sorry, this is cos a, this is cos c minus cos b, and this is 1 1 gets cancelled out, cos b gets cancelled out. So we have cos c minus cos a. This is equal to 0. Now this is the product of three terms equals 0. So we have either cos b equals cos a, or we have cos c equals to cos b, or we have cos c equals cos a. So we can see that either any one of them must be equal to 0. So if we take this is equal to 0, this result will obtain. If we take this is equal to 0, this result will be obtained. And if we take this is equal to 0, this result will be obtained. So from this we have a equals to b, from this we have b equals to c, and from this we have a equals to c. So we can see that triangle ABC is isosceles, because it may happen that a equals to b equals to c. In that case, the triangle becomes equilateral also, but we have minimum one of them equal to 0. So if we take minimum one of them equal to 0, because product of these three equals to 0, so one of them should be 0. It may happen that two of them is 0. If we take two of them equals to 0, then we get the triangle is equilateral, because if we take this is equal to 0, we get a equals to b. If we take this is equals to 0, we get b equals to c. So consequently we have a equals to b equals to c, but it is not sure that two of them equals to 0 or three of them equals to 0, but it is sure that one of them is clearly 0. So if we take one of them equals to 0, we get any of the two angles is equal, and if any of the two angles is equal, the triangle is clearly isosceles. So this is the minimum criteria. So don't be confused that why not the triangle is equilateral. The triangle may be equilateral if two of them equals to 0, but it is confirmed that the one of them should be 0 as the product is 0. So this is confirmed that the triangle is isosceles. Next sum we have it is given that if a plus b plus c not equals to 0, this is given that a plus b plus c not equals to 0, and determinant a b c b c a c a b, this is equal to 0, then we have to prove that a equals to b equals to c, then prove that a equals to b equals to c. This is a different type problem, so we have to practice mostly different types of problems. If we practice every day, each and every day same type of problems, so chances of getting common in exam becomes very less. So we try to solve different types of problems. So what we do, First we operate R1 operating R1 plus R2 plus R3. That is, we are going to add R1 with R2 and R3. So if we add, then we have A plus B plus C, A plus B plus C, and here also A plus B plus C. Then we have B, C, A, C, A, B, and this is equal to 0. So we can take A plus B plus C common out of the determinant. Then we have 1, 1, 1, B, C, A, C, A, B. This is equal to 0. Now we see that this is the product of two terms. One is a determinant and one is an element, A plus B plus C. But it is given that A plus B plus C not equals to 0. Please pay attention. It is given that A plus B plus C not equals to 0, despite we have A plus B plus C into this equals to 0. So if this the product is equal to 0, we conclude that either this is 0 or this is 0. But it is already given that this is not equal to 0. So what is our conclusion? So this implies this determinant equals to 0. Because if the product of two terms is equal to 0, one of them must be 0. And already it is known that one of them is non-zero. So it is clear that the other one is 0. Otherwise this product cannot be equal to 0. Now we have to simplify this determinant. We have here 1, 1, 1 format. So we will try to make it 1, 0, 0. So we try to make it 1, 0, 0. So we write here 1, 0, 0. So what we operate? We operate C2 operating C2 minus C1 and C3 operating C3 minus C1. Or we can write C2. This is equal to 0. It is already given. So we have here BC and we have here C2 operating C2 minus C1. So this is C minus B, A minus C. Then we have C3 operating C3 minus C1. So we have here A minus B and then B minus C. So what we get? We get the structure of 1, 0, 0. So we delete R1 and C1. So we get determinant C minus B, A minus B, A minus C, B minus C. This is equal to 0. Now we have to expand this determinant to get the required result. So expanding, we have C minus B into B minus C. Then we have plus, then we have minus, compulsory minus for determinant, A minus C into A minus B. This is equal to 0. Now C minus B and B minus C, if we take minus common, then we have this is B minus C. So taking minus common, we have this is equal to B minus C, because it is C minus B. So we want to take minus common from this. So taking minus common, we will have this is B minus C and this is B minus C whole square. So we will have minus sign out of this, and here we can also minus. So we cancel minus in both the terms. So we have B minus C whole square plus A minus C into A minus B. This is equal to 0. So simplifying, we have B square plus C square minus 2BC plus A square minus AB minus AC plus BC. This is equal to 0. So what we see, we get the value A square plus B square plus C square minus AB minus BC minus CA. This is equal to 0, because it's minus 2BC plus BC, so it is minus BC minus AB minus CA. This is a very lengthy sum and my board is not too big, so it creates very problem. So I have to rub the board again and again. So now we have this value. Now from this value we have to get the required result. So what we do, we multiply the term by 2. So we get 2A square plus 2B square plus 2C square minus 2AB minus 2BC minus 2CA equals 0. Now we will form 3 perfect squares from this expression. So we get this as A minus B whole square plus B minus C whole square plus C minus A whole square equals 0. So what we have done, we have taken 2A square, we have taken 1A square, then minus 2AB and 1B square. So it forms A minus B whole square. So we have one more A square, and this A square we have used 1. So 1A square, 1 minus 2CA and 1C square. So we are left with 1b square and 1c square together with minus 2bc, and that forms b minus c whole square. Now we know that if the sum of three squares is equal to 0, so individually they equal with 0. So from this we have a minus b, this is equal to 0, b minus c, this is 0, and c minus a, this is 0. So this implies a equals to b, this implies a equals to b, this implies b equals to c, and this implies c equals to a. So from this we have a equals b equals c. This was our result to prove. This is a very different type of determinant, so please practice the determinant. Next we have one more sum. The sum is, it is also a very different type of problem, so practice this sum regularly until you confirm that the sum is ready. So what is given? We have to find limit t tends to 0 ft by t square, where ft equals determinant cos t t1 to sin t t to t, and sin t t t. Believe me, this is a 2 marks problem. Seeing the problem, many of you may think that it is not a board level problem, it is J level problem. But it is not at all a J level problem. It is a very easy problem, one of the most easy problem. Okay, so let's try to solve it. So first we find that ft by t square, what is the value? Ft by t square equals, now we have this is equal to ft. This is your ft. Now ft, this ft is divided by t square. So we are going to divide this determinant by t square. Now listen very carefully. We are going to divide this determinant by t square. So what we do, we choose one row, any one row. Later I will tell you which row to choose. One row we have to divide by t, and another row we will divide by t. Now the first row, if we divide by t, we get cos t by t. Now cos t by t limit t tends to 0 does not give any formula. Okay, so we will ignore row 1. So let us choose row 2. In row 2, if we divide by t, we have sin t by t. Sin t by t limit t tends to 0 gives 1. And this t becomes 1 and this becomes 2. So row 2 is safe to choose. Next we proceed to row 3. Here also sin t is there, so we can allow one more t here. That is, our target is to divide ft by t square, and we will divide t square in two processes. One by row 2 we will divide by t, and again row 3 will be divided by t. In this way ft will be divided by t square, step by step. So first we write, this is no change, that is r1 is unchanged. Now we change r2 divided by t. So it is 2 sin t by t, this becomes 1, this is 2, and this is sin t by t, this is 1, this is 1. Now after this, this is ft by t square. We have to find limit t tends to 0 ft by t square. So we find limit t tends to 0 ft by t square, this is equal to, now limit t tends to 0, this is ft by t square. On the board, this is your ft by t square. We are applying limit to it. Now we know the property of limit, limit of sum equals to sum of the limits, or so limit of the determinant, what is the result? If we apply limit in a determinant, so limit will be applied to each and every element of the determinant. Again I am saying, if you want to apply limit in a determinant, so limit will be applied to each and every element in the determinant. So applying this limit t tends to 0 to cos t, it becomes 1, because we know that limit t tends to 0 cos t equals to cos 0, which is 1. Now limit t tends to 0 t, which is 0, limit t tends to 0 1, 1 is a constant, so there is no change in the limit, so it becomes 1. Now limit t tends to 0, 2 sin t by t, sin t by t is 1, so it becomes 2, because sin t by t is 1, so 2 into 1, it is 2. Now it is 1 being a constant, so no change, 2 1 2. Here sin t by t it is 1, it is 1, it is 1. So we get this simplified determinant. Now we have to expand this determinant. So expanding, we have 1 into, this is 1 minus 2 plus 0. So we will not write because 0 into anything is 0. So plus 2 into 2 minus 1. So what is the result? It is minus 1 plus this is 1, 2. So the result becomes 1. So the value of this determinant is 1. This is 1 minus 2, 0, no change. So plus 1 into, sorry, this is plus 1 into, this is plus 1 into 2 minus 1. So the value is minus 1 plus 1. That is the value is 0, not 1. So this is minus 1 plus 1 is 0. So this is a very different type of problem. So these type of problems we have to practice, and we can see the length of the answer. It is clearly of 2 marks. So please practice this sum regularly.